So in this question, we've got some information presented to us in terms of chromatography results. We are being asked to identify which one contains a single dye. So remember, if they are single, then they will contain just one sample produced when you run the chromatography experiment. So this one here, ink Z, is going to be the one that has one, and hopefully that is one of the options, and it is. So here we're going to go ink Z is the one. Next one says which one contains the greatest number of dyes. So the way we work that out is we look at how many dots each one of these contains. So if we look at this first one, we've got 1, 2, 3 dots. X has got 1, 2. Y's got 1, 2, 3, 4. And we've already said Z's only got 1. So the one with the most in is this one, because each dot represents a different colour, and therefore we've got Y as the answer, which is that one. Okay. Next one is based on the information we've got here to calculate an RF value. They're actually helping us by telling us that the RF value equation and what it is. So if we have a look in the question, we need to see that at the end of the chromatography, one dye had moved 3.6. We've got a travel for the dot of 3.60, and the water front, or the solvent front, sorry, has gone 9.20. So you put those two into your calculators, you'd work that out. That's given me an answer of 0.391304. Be careful, because here it wants it to 2 decimal places. So what you'd have to do is you look at 1, 2, and 3. Number 3 is a 1, so that's going to become to 2 decimal places 0.39 as your final answer. Okay. In terms of marks, they give you a mark for doing this bit right, and then a mark for giving that in the right format. Okay, next one. We've got a heating curve for a substance, and it says from A to B it was a liquid. I'm going to add that to, it's added already first, so it's a liquid, and C to D is a gas. Give the name of the change when a liquid becomes a gas. So a liquid becomes a gas. You could have two possible answers to this one. You could say that a name is boiling, or you could have said evaporation is also the name for that change. Use figure 2 to give the temperature of the substance at 4 minutes. What we have to do here, I'm going to zoom in a little bit, is we go to 4 minutes and we follow that line up to where it meets here, and then we're going to take that line back across, and it's gone this way. So that's going to be, use my laser pen, that's going to be 52, 54, it's going to be 56 degrees at that particular point. So let's put here 56. Oh, hang on, sorry, wrong space. That one there is 56, isn't it? So 56 there. Okay, this one says, use figure 2 to give the time when the substance has completely changed into a gas. So remember, when this is changed into a gas, that's this flat part of the graph just here. And the time that ends is at 6 minutes. You can see here that's 6 minutes. And the time it started to change is 3 minutes. So what's the question asked us? Give the time when it completely changes to gas. That's going to be 6 minutes is the time that happens. The temperature of A was 25. Give the temperature rise. Okay, so here at this point, we're told it is 25. If we come up to here, I'm going to draw a line across. So it sits in there. I can see from that line that's 75, because here we have got 72, 74, and it's halfway, so 75. So in my calculation, I've got a temperature change that, where's it gone? That ended at 75, started at 25, so the temperature change is going to be 50.